Let's consider the hydrogen atom. It consists of a proton in the nucleus, and that's the nucleus, and an electron outside of the nucleus. And we can solve the equations of motion for the electron and the hydrogen atom, and we can obtain what are called a set of energy levels. That are available for the hydrogen atom. Now the energy of the hydrogen atom depends upon a quantum number called n, we'll discuss later, is equal to negative, and we have a constant which we call R sub h, h stands for hydrogen, divided by n squared, and n is an integer and it ranges from 1 to infinity. Now we have the negative sign in the energy expression because we pick the 0 point of energy as the separated proton and electron. So if we completely separate the proton and electron, we dissociate the hydrogen atom. And then the proton and electron, at infinite separation, the attraction between those two particles goes to 0, and so there's no attraction. If we let the proton and electron come together, they attract each other because they are oppositely charged particles. Opposite charges attract. Then that attraction we signify as being less than 0 for the energy, and so that's why we have the negative sign, just to where we picked our 0 point. So the most negative or lowest energy for the hydrogen atom is when n equals 1, so E sub n is equal to minus R sub h over 1 squared, and R sub h is 2.18 times 10 to the negative 18th joules. So this is the lowest energy level for the hydrogen atom, where n equals 1. The next highest energy would be for n equal 2. So that would be minus R sub h divided by 4, because we square the quantum number n. So the next energy would be equal to minus 5.5 times 10 to the minus 19th joules. Now you can see, since n goes from 1 to infinity, we have infinite number of energy levels possible for the hydrogen atom. And if we put it on an energy scale, our energy increases that way. We'd have n equal 1, n equal 2, n equal 3. These are not necessarily to scale. N equal 4, n equal 5. So they get closer together as we go up in n value. So the energies get closer together as n increases. Now the significance of the quantum number n, is that it makes it so that only certain energies are available to the hydrogen atom. N has to be an integer, 1, 2, 3, 4, etc. And so only those particular values are available for the stationary states of a hydrogen atom. We say the energy is quantized energy levels.